Hey, you are watching AliAziz YouTube channel.
Top 15 Aerospace Engineer Interview Questions and Answers.
AliAzizQualityEducation channel providing you the job best interview related videos, so don't forget the subscription button.
1. Talk about the negative effects that can come from loading an aircraft in an extreme tail-heavy manner. To start with, the first negative impact that a heavily loaded aft has on an aircraft is a nose that pitches extremely upward during flight, and this can cause major issues for the pilot, like a power-on stall. These problems weigh the most heavily on the pilot during takeoff, landing and during flight. Because too heavy of a weight in the rear of an aircraft has a negative impact on longitudinal stability, light control forces make the possibility of overstressing an aircraft much greater. 2. Talk about a home project that you are working on or recently worked on. How is this relevant to your career? A current colleague of mine really got me into creating my own flight simulation program using MATLAB. I've always been very fascinated with the navigation and controls side of flight, and this project has been a blast to help my teenage daughter become interested as well. We spent a couple of Saturdays with my colleague learning the ropes of creating flight simulation, and now we are off and experimenting on our own and loving it. 3. What software and coding skills have you developed over your career? Throughout my career to this point, being 6 years out of college, I feel very fortunate to have been exposed to a wide variety of design and analysis software. I am very fluid in CAD/CAM drawing programs, and also am very skilled in ANSYS simulation and design software. I am very fluent on just about any software program, and if hired for this role, I wouldn't have any issue learning and becoming fluent in any new programs. I have also been trained in C programming at my current job and am confident in my ability with that as well. 4. How does inclination of an airfoil affect the lift of an aircraft? An airfoil is an important component in any aircraft to help the craft take off or make elevation changes while in flight. On airplanes, they are most common on the wing section. The basic principle is that as the airfoil is inclined, the airflow coming at the aircraft produces both lift and drag that help the aircraft climb in the air. In theory, the greater the inclination means the more lift. But, basic physics principles such as friction can cause air stalls if the inclination is too high on the airfoil. In basic design principles, slower aircraft that generally carry heavier loads utilize thick airfoils that produce a high amount of lift and drag. Conversely, high-speed aircraft utilize very thin airfoils for lower drag and lower lift. 5. In what situations does it make sense to measure absolute pressure, and what situations does it make sense to measure gauge pressure? Because gauge pressure measures is directly influenced by changes in atmospheric pressure, it is best used in measurements where a tight seal is not creating a vacuum effect. One of the most common gauge pressure measurements on an aircraft is in the tire pressure, because atmospheric pressure has a direct effect on that measurement. On the other hand, absolute pressure measures pressure in a true vacuum situation with a tight seal. This is most often used to measure amounts of fuel in a sealed tank. There are also situations where a differential pressure gauge is used to detect the difference between these two pressures, and an airspeed indicator is a very common gauge for this. 6. What techniques do you use to efficiently and effectively manage your time in your work as an aerospace engineer? As a firm believer in my Outlook calendar and tasks list, I utilize that technology on the go all day long to keep a running tasks list. At the end of each workday, I always carve out 20 minutes or so to update my accomplishments for the day and add new things to my list. I remain focused on the most important items and am always ready for an urgent challenge to get thrown my way. As we both know, this happens frequently in our world. Right now in my current job, I also am tasked with managing some of our largest projects, and I hold time on my calendar for project team updates on a weekly basis, and I put a strong focus on meeting deadlines that we set as a team. 7. Why is fatigue stress testing so important for aluminium alloys used in the aerospace industry? A reality in the aerospace industry is that most aluminium alloys we use have been subject to high cycle fatigue testing, but the HCF testing just doesn't do a material justice when looking at the stress that an aircraft puts its materials through. In a much better testing scenario, I only trust materials that have been subject to low cycle fatigue testing that utilizes high amplitude, low-frequency strains that better test for materials in conditions with changing temperatures and cyclical conditions. 8. Explain the science behind how a petard tube works in aviation. While petard tubes have use in many different industries, no industry is more controversial in their use than the aerospace industry. They are a great tool that measures the stagnation pressure as air moves into the tubes. Then as air passes through, a side hole in the tube measures the static pressure. Based on the simple Bernoulli's equation, the tube can then measure the dynamic pressure and be used to calculate the velocity of the aircraft. In more recent years, several major flight crashes have been linked back to malfunctions in the pilot static system that included a petard tube and petard static instruments for the pilot. I'm very familiar with some of the new petard tube designs that do a great job of limiting ice formation and have used these in more recent designs. 9. What is fuel weight fraction and how does it impact total fuel consumption when planning flight? In the simplest terms, the fuel fraction is a calculation of the weight of the fuel in the aircraft divided by the total takeoff weight of the aircraft. For most commercial airlines that fly long haul, a fuel fraction of close to 50% is often needed to ensure that there is enough propellant to make the entire flight path. Other shorter haul planes and military aircraft have much lower fuel fractions and often perform better overall because of the minimized weight. 10. How do you define the standard lapse rate and what part does moisture play in changes to the rate? In my work, I define the standard lapse rate as a 3.5 degree F change in temperature for every 1,000 feet of elevation change in flight. In drier conditions, that change can be more significant and reach up to a 5 degree change every 1,000 feet. In more moist conditions, the change is less at more around 2 degrees Fahrenheit per 1,000 feet in elevation change. The knowledge of the lapse rates has sure-changed flights for pilots as the weather now plays a significant part in creating flight plans, and a traditional West Coast to East Coast flight could have very different path depending on the day and the weather. 11. How do you stay up to date on the latest technologies in the aerospace engineering field? As a firm believer in professional development and personal growth as an aerospace engineer, I'm happy to say that I belong to the Aerospace Industries Association and the American Institute of Aeronautics and Astronautics. Over the past 5 years, I have participated in many of the AIAA courses offered online. Recently, I attended a technical writing course that really helped me develop new skills. On top of these organizations, I also subscribe to Science Daily and the NASA website for news in our field. 12. What would you say is your least favorite part of being an aerospace engineer? Up to this point in my career, I would say the least favorable aspect has been the instability of funding at places I have worked. Because of this instability, I've had many close colleagues that were great at their job get let go from their positions simply because the funding for projects wasn't there. While certainly sad to see close colleagues move on in circumstances out of their control, this fact has pushed me to become the best at what I do. 13. What is a canard and what are the advantages to utilizing them on an aircraft? A canard is a small wing section mounted in front of standard wings on an aircraft, and they definitely have their place in air travel. They are most utilized to help provide more stability and lift to certain planes that can benefit from that design. They have also been used in designs to solely aid in stability on aircraft that have been unstable in pitch to help decrease the workload of the pilot in flight. 14. What made you interested in a career path in aerospace engineering? I have always been fascinated by flight. As a child, I would spend hours watching airplanes take off and land at the nearby airport. I was amazed by the engineering that went into these machines, and I dreamed of one day being able to work on them myself. 15. What exactly do aerospace engineers do? Aerospace engineers evaluate designs to see that the products meet engineering principles. Aerospace engineers design, develop, and test aircraft, spacecraft, satellites, and missiles. In addition, they create and test prototypes to make sure that they function according to design.